Good morning, class 9th. We are starting the next chapter in your syllabus, which is logarithms. Today we are going to introduce you to the logarithms. We have already finished with you the exponents, and exponents and logarithms are correlated. That is why it is very obvious that we are going to discuss this chapter now. What is logarithm? Actually, why complicate mathematics which is already very complicated for most of the people? Logarithm is a mathematical tool which makes things very simple, like the processes of multiplication and division, which are difficult, are converted into addition and subtraction with the help of logarithms. So logarithm is a tool which makes process simple, mathematical process simple. Though with the invent of calculators and computers, then things have become very simple. But even then, logarithm is a mathematical tool which is very, very important. So today we are going to study about this tool. Another thing which you have to remember and keep it in your mind, like these are exponential forms I have written. If I raise 2 to the power 3, I get 8. If I raise 3 to the power 2, I get 9. If I raise 5 to the power 4, I get 625. If I raise 2 to the power minus 3, I get 1 upon 8. If I raise 10 to the power minus 2, I get 1 upon 100. 10 to the power 0, any non-zero number risen to power 0 is 1. 10 to the power 1 will remain the same, 10. 10 to the power 3 will become 1000, not 100, it will become 1000. And suppose in general a to the power b is equal to c. Please remember, exponent is the log. Exponent, these are exponent 3, 2, 4, minus 3, minus 2, 0, 1, 3, b. These are all exponents. Exponent is logarithm. Exponent is logarithm. How do we get it? We start from here. We'll start from here and go this side. We'll say 3 is the log of 8 to the base 2. 3 is the logarithm. We said exponent is logarithm. 3 is the log of what? This number to base this. 3 is the log. In short, we write LOG, log to the base 2. The exponent 3 is the logarithm of the number which has been obtained by raising some number. We have obtained 8. So 3 is the log of 8 to the base 2. We said start from here. And if I want to convert from logarithm to exponential, I will start from here. 2 to the power 3 is 8. So both the exponential form and logarithmic forms are interchangeable. They are interchangeable. For example, 3 to the power 2 is 9. Then 2 will be called the logarithm of 9. The exponent 2 is called the log of the 9, whatever number you obtain to the base 3. This is the base. The number which you've raised to the power is the base. 2 is the logarithm. Answer will be log 9 to base 3. Now here 4 is the log of 625 to the base 5. If I raise 5 to the power 4, I'll get 625. If I raise 5 to the power 4, I'll get 625. Similarly here minus 3, 2 has been raised to minus 3 and we get 1 upon 8. So minus 3, as I said, exponent, if you see here, exponent is logarithm. This is very important. If you remember this, you will not make a mistake. Exponent is logarithm. Minus 3 is the logarithm of that number which you have obtained, that is 1 upon 8. And to what base? 2. And if you raise 2 to the power minus 3, you will get 1 upon 8. So these kind of questions you will get quite often in this chapter, that convert logarithm into exponential form or exponential form to logarithmic form. Like it is 10 to the power minus 2 is 1 upon 100. 10 to the power minus 2 is 1 upon 100. So minus 2 exponent, whatever exponent, that is the logarithm of which number? Which you have obtained as answer. That is log 1 upon 100. To what base? Base 10. Then 10 to the power 0 is 1. A non-zero number risen to power 0 is always 1. So log 1 will be always 0. Log, this exponent is logarithm. So 0 is the log of this number 1 to the base 10. Log 1 to any base will be 0. Log 1 to any real number will be 0. Log 1 is 0. Now 10 to the power 1 is 10. So 1 will be log 10 to the base 10. The exponent is the logarithm of this number to this base. 3 is the logarithm of 1000. 3 is the logarithm of 1000 to the base 10. And here b will be the log of number c. The power or the exponent. Exponent is b. So b will be the logarithm of c. Logarithm of c to the base a. So from logarithm, from exponential form, I have converted to logarithm form, explaining to you that how do we get. Exponent is the logarithm. This is very important to remember. Exponent is logarithm. Exponent is logarithm. Whenever you get the exponential, exponent will be your logarithm. Like 3 is the log of 8 to the base 2. 2 is the log of 9 to the base 3. 4 is the log of 625 to the base 5. Minus 3 is the log of 1 upon 8 to the base 2. We are going like this. 4 is the log of 625 to the base 5. Minus 3 is the log of 8 to the base 2. Minus 2 is the log of 1 upon 100 to the base 10. 0 is the log of 1 to base 10. 1 is log of 10 to the base 10. These are just, I'll explain it to you, these are important things also. 10 to the power 3 is 1000. So 3 is the log of 1000 to the base 10. And if a to the power b is equal to c, then the exponent b is the logarithm of the number c to the base a. When I say 10 to the power 0 is 1, log of 1 to any base, log of 1 to any base will be 0, because instead of 10, suppose it was 2 to the power 0, we would have got 1. If it was 3 to the power 0, I have got 1. If it is 5 to the power 0, I would have got 1. So, whether log 1, 0 is the log of 1 to base 2, 0 is the log of 1 to base 3, 0 is the log of 1 to base 5. So 0 logarithm of 1 is always 0 to any base, not necessarily to the base 10, not necessarily to the base 10. Another thing which is important here is 10 to the power 1 is 10. 10 to the power 1 is 10. So log 10 to the base 10 is 1. When the number and base is same, when the number and base is same, the logarithm will be always 1. If the base is same, if the base and the number is same, for example, if I say 2 to the power 2, what will it be? If the base and the number is same, for example, if I write here log 2 to the base 2, log 2 to the base 2, or log 3 to the base 3, or log 4 to the base 4, what will be the number which I will obtain? How do I get that? Like log 2 to the base 2, suppose as x. Log 2 to the base 2 is x. So when we change from logarithmic form to index form, what do we get? How do we get? We go from here to this side and get this. 2 to the power x will be equal to 2. 2 to the power x will be equal to 2. That means 2 to the power is how much x? So x will be 1. So when the base is same, the logarithm will be 1. Like it is log 3 to the base 3 is equal to x. So 3 to the power x will be 3. 3 to the power 1, x is equal to 1. So whether you calculate it 4 to the base 4, you will get the value of x as 1. Once again I will go through the complete thing. 2 to the power 3 is 8. The exponent is called the log of the number which we obtain to the base, to which we have raised to get the number 8. So log 8 to the base 2 is 3. 2 is the log of 9 to the base 3. 4 is the log of 625 to the base 5. Minus 3 is the log of 1 upon 8 to the base 2. Minus 2 is the log of 100 to the base 10. 0 is the log of 1 to base 10. 1 is the log of 10. 1 is the log of 10 to the base 10. 3 is the log of 1000 to the base 10. B is the log of C to the base 10. Log base A. Another thing, logarithm of a number with the same base is always 1. Logarithm of a number with the same base is always 1. And logarithm with base 10 are called common logarithms. Logarithms with base 10 are called common logarithm, like this. These are common logarithms where the base is 10. Where the base is 10. Wherever the base is 10, they are called common logarithm. Wherever the base 10 is there, you will get common logarithm. Base can be anything depending upon how we have raised the power. But whenever the bases are 10, they are called common logarithm. For the practice, we have written some exponential forms and some logarithmic forms. From exponential form, we want to change them to logarithmic form, and from the logarithmic form, we want to change to exponential form. It is very important because once you understand the concept of exponents and logarithms, it will be very simple for you. That is why we are doing more questions based on this. 10 to the power 4 is 10,000. We told you that exponent is always logarithm. So 4 will be log. 4 will be log of what? What number you have obtained. Log 10,000. And what is the number left? 10. So log 10,000 to the base 10 is 4. Minus, exponent is the logarithm. So minus 5 is the logarithm of what? You have obtained what? X number to the base 3. Now 3 is the exponent here. So 3 will be logarithm. 3 will be logarithm of the number which you have obtained, 0.027 to the base 0.3. So we converted the exponential form to the logarithmic form. We went from here to here. We went from here to here. If you remember this way, it will be easier. 4 is the log of what? 10,000 to the base 4. Minus 5 is the log of x to the base 3. 3 is the log of 0.027 to the base 3. And if you reverse this, you will get the exponential form. Like now I have, these are logarithmic form. From logarithmic form, I have to change it to exponential form. Like 3 to the power 4 will be 81. 3 to the power 4 will be 81. Why? 4 is the log of 81 to the base 3. 4 is the log of 81 to the base 3. Or 3 to the power 4 is 81. 8 to the power 5 upon 3 is 32. You go from here to here. Similarly, 10 to the power 1 will be equal to 0.1. 2 to the power x is 16. 2 to the power x is 16. That means 2 to the power x is 2 to the power 4. 2 2s are 4, 2s are 8, 2s are 16. So x is how much? 4. If bases are same, powers are equated. Because base is 2 here, base is 2, powers can be equated. So it was corresponding to this. Now 3 to the power x is equal to 1 upon 3, or it is 3 to the power minus 1. 1 upon 3 means 3 to the power minus 1. So that will imply x is equal to minus 1. Because bases are same, powers equated. Now root 2 to the power x, root 2 to the power x will be equal to 8, because x is the exponent is the, x is the logarithm of 8. X is the log of 8 to base root 2. That is what it is given here. Now what will happen is 2 to the power half x, because root means half, and it is 2 to the power 3. That means half x is equal to 3, or that will imply x is equal to 3 upon 2. X will be 6. 3 will go up, x will become 6. X will become 6. Because half x is equal to 3, so x will be equal to 6. The last one is 5 to the power x. 5 to the power x will be 0.008. You have to again calculate the value of x. You have to calculate the value of x. 0.008 means what? It means 8 upon 1000. Because after decimal 3 digits are there. So if you remove the decimal, you get this. Now what will you get? 4 2s are 2 4s are 8, suppose 500, then 2 2s are 4, 250, then 2 125. So it is 1 upon 125. It is 1 upon 125. That means 5 to the power x is equal to 5 to the power minus 3, because 1 upon 125 means 125 to the power minus 1, and it is 5 to the power 3 to the power minus 1 will be 5 to the power minus 3. So it is 5 to the power minus 3. It is 5 to the power x, it is 5 to the power minus 3. So x will be how much? Minus 3. So few questions were from exponential form to logarithmic form, and then from logarithmic form we changed them to be exponential form. Power or the exponent is always the log. You go here, 4 is the log of 10,000 to the base 4. If you want to come from here, then 8 to the power 5 upon 3 will be 32. If you want to change, you remember one way and you would be able to remember another way. It's the easier way. I'll tell you very, very easy way to remember it also. Just remember tens. 10 to the power 2, everyone knows is 100. And 10 to the power 3 is 1000. Everyone, and you can keep taking the multiples of 10. Log of 100 is always 10. Log of 100 is always 2, always 2 to the base 10. Log of 1000 is always 3. So, if whatever the number of zeros, 100 is 2, 1000 is 3, but remember the base has to be 10. Base has to be 10. Base has to be 10. If it is something else, then it cannot be. And this can make your basis for remembering it. That 10 to the power 2 is 100. 2 is called the log of 100 to the base 10. 3 is called the log of 1000 to the base 10. And if you convert 10 to the power 2, it will be 100. 10 to the power 3 is 1000. If you remember this, you will have no issues in remembering exponential form or logarithmic form. Okay, we have written down some questions where he has given certain logarithmic form, and from that we have to calculate the value of x. We have to calculate the value of x. Let's take one by one. Question number 1 is log 1728 to the base 2 root 3 is equal to x. We have to find out the value of x. So that means I have to convert logarithmic form to index form to get the value of x. And we told you how do we get the index form. We go from here to here. The base is written to the power x to get this number. The base, that is 2 root 3, has been risen to the power x to get number 1728. So it is 2 and 2 to the power x, and it is 3 to the power half x. Why? Because it is root 3. So 2 to the power x and 3 to the power half x. Now 1728, I must find the prime factors of 1728. I should be able to get the values of prime factors of 728 in terms of 2 and 3. Then only I can equate. Let us see. 2 8s are 16, 2 6s are 12, 2 4s are 8. 2 4s are 8, 2 3s are 6, 2 2s are 4. 2 2s are 4, 2 1s are 2, 2 5s are 10, 2 4s are 8, 2 2s are 4, 2 7s are 14, 3 9s are 27, 3 3s are 9, and 3 1s are 3. So I have got the prime factors of 1728, which you do in HCF and LCM. So 1, 2, 3, 4, 5, 6. So 2 to the power 6 and 3 to the power 3. Now if you look at this equation, you have got the values. You have got the power x. 2 to the power x, 2 to the power 6. So number 1, 2 to the power x is equal to 2 to the power 6 will imply x is equal to 6. We have got the value of x from here, 6. Now let us see. 3 to the power half x is equal to 3 to the power 3. Again, half x is 3. So x will be how much? 6 only. So whether you use this, whether you use this, the value of x remains the same, because in this question x cannot change. X cannot change. 2 root 3 risen to power 6 will give you 1728. 2 root 3 to the power x, that is we have calculated to be 6, will give you the number 1728. This is first question. Let me see the second question. Log x to the base 2. Log x to the base 2 is 5. I have to find out the value of x. So again we are changing from logarithmic form to index form. That is log x to the base 2 is 5. So what I'll write is, again 2 to the power 5 is equal to x. 2 to the power 5 is equal to x. 2 to the power 5 is x. So x is how much? 32. 2 to the power 5 is 32. So the value of x is 32. Now let us see question number 3. Just look at the question number 3 and think about it. Question number 3 is log x to the base 4 is 2 upon 3 is equal to 2 upon 3. Again 4 will be risen to power 2 upon 3 to get the value of x. 4 will be risen to power 2 upon 3 is equal to x. 4, I told you, remember this. The arrow goes like that. 4 risen to power 2 by 3 will give you x. Now 4 to the power 2 upon 3 means 2 to the power 2 into 2 upon 3. It will become how much? X is equal to x is equal to 4 is to 2 upon 3 only, or x is equal to 2 to the power 4 upon 3. That is the value of x. The value of x is 4 to the power 2 upon 3. That is the value of x. Now let us see question number 4. Log x to the base root 3 is equal to 4. Again, root 3 to the power 4 is x. Root 3 to the power 4 will be x. Root 3 means 3 to the power half. 3 to the power half into 4 is x. So 2 to the 4, or x is 9. The value of x is 9. This is question number 4. Now let us see question number 5 after this. Log 243 to the base x is equal to minus 5. So x to the power minus 5, x to the power minus 5 is 243. And 243 is actually 3 to the power 5. It is 3 to the power 5. So it is x to the power minus 5. It is 3 to the power 5. The powers are not the same. The powers are not the same. Powers have to be the same. Then only I can equate the bases. So x to the power minus 5, and I can write 1 upon 3 to the power minus 5. If I want to change the sign of the index from plus to minus, I must bring the numerator to denominator. That is 3 comes down to 1 upon 3. So both the powers become same. So that will imply x is equal to 1 upon 3. You get the value x is 1 upon 3. Now let's see question number 6. Log 16 to the base x is equal to 2. Again, x to the power 2 will be 16. X to the power 2 is 16. When I change from logarithmic form to index form, and 16 means 2 to the power 4. 2 to the 4 to the 2 to the 2 to the 4 to the 8 to the 16. 2 to the power 4. But it is x square is 16. I want 4 to the power 2 because I want the powers to be the same. So it is power 2, it is power 2, so x is equal to 4. Then only we can equate. If the powers are same, then only we can equate the bases. Now let us see question number 7. Question number 7 is log 27 to the base 9 is equal to 2x plus 3. So 9 to the power 2x plus 3, again it will go like this. 9 to the power 2x plus 3 is equal to 27. And what is 27? 3 to the power 3. 3 3s are 9, 3s are 27. Now here the powers are same, now the bases are same. 9 can be converted. How? 3 to the power 2 into 2x plus 3 is equal to 3 to the power 3. So bases are same here. Here bases are same, so the powers could be equated. So powers will be 4x plus 6 is equal to 3, or 4x will be 3 minus 6, that is minus 3, x will be minus 3 upon 4. This is the value of x. Let's see question number 8. Log 3x minus 2 to the base 10 is equal to 2. We have to calculate the value of x. So 10 to the power 2 will be equal to 3x minus 2. That is 3x minus 2 is equal to 100. 3x will be 102. 3x will be 102. So x will be 102 upon 3, that will be 34. If 102 is divided by 3, we get 34. So the value of x is 34. Now let's see question number 9. Log 64 to the base x is equal to 32. Sorry, 3 upon 2. Again, x to the power 3 upon 2 will be equal to 64. It will be 64. Now, how are we going to do 64 to the power 3 upon 2? So, let us see what do we do. 64 is what? 2, 3 is 6, 2 2s are 4, 2, 16, 2, 8, 2, 4, 2 2s are 4, 1, 2, 3, 4, 5, 6. 2 to the power 6, and it is x to the power 3 upon 2. So, how are we going to calculate x? X will be equal to 2 to the power 6 into 2 upon 3. We take the power from this side to that side, it becomes 2 upon 3. So, 3 2s are 6, so 2 to the power 4. So, x is equal to 60. X is equal to 60.